if your speed is increasing and increasing and increasing and it keeps on increasing, will there be a final point at which it might be very, very dangerous to your body itself, that you might not be physiologically able to deal with that? Well, to tell you that you are right now traveling at a speed of 1,07,000 km per hour around the sun. Okay, so with respect to the sun, obviously the earth is spinning on its own axis and it's also moving around the sun. So if you take all those relative velocities accordingly, we have this calculation that your speed, or now obviously this depends on where you are on the earth. Okay, so if you are near the pole, your speed would be different. If you are at the equator, your speed would be a little bit different. But if I take a general average value, that is somewhere around this, which is 1,07,000 km per hour. So it's already a very high value of speed and you are moving on that speed. But why is it not dangerous? The thing is, this is more or less of a constant velocity. Okay, so that means there is not much acceleration that you feel. Although there is a bit of centripetal acceleration that you have on your body towards the sun. Okay, and in that case, what basically this is, it's just hundreds and hundreds and hundreds of years of evolution, and it's just that we have become habitual of that amount of acceleration, and that's not very huge. Okay, so even when you're moving at such a high speed, but because there is no change in speed, the speed is just constant, we can easily survive any realistic velocity as long as it is constant. Or even if there is a change, the change is not very high, the change is very, very slow. In that case, you will not feel much of different things on your body. But acceleration can make things different. That means the amount of acceleration, that if it is very high, it can be very difficult, okay, for our body to deal with it. Let's see this example. Okay, and the basic example and testing that has been done is on the fighter jets. Even in India, the Air Force pilots who go through all this training, they are trained for such high acceleration, because in a fighter pilot, it's already moving at a very high speed. Okay, and in that case, they have to deal with high precision maneuvers in which the aeroplane has to change its speed, it has to change its direction, and while the aeroplane is taking a very high precision like this, a turn or a very tight turn in the air, in that case the pilot feels a huge amount of acceleration on his body, and these huge amount of acceleration can actually be deadly. Okay, they can actually drain the blood out of the brain, or they can put a lot of blood into your brain because of such high accelerations. As a result, there may be some rupture or brain hemorrhage, and the pilot might simply faint in the aeroplane, and it can be very hugely catastrophic. Okay, so high accelerations can be deadly. So now if I put a number to this, that means what exactly is the amount of acceleration at which it can be very, very difficult for a human being, and that has been tested. Okay, so this is a fun activity. Here I'm going to tell you a very interesting fact, that what exactly is that acceleration, and humans have been known to survive accelerations as great as 440 meter per second square. This is incredible speed. Okay, not speed actually, this is incredible acceleration. Now it's your task to convert this acceleration into kilometer per hour. Okay, do this at your home, get a realistic idea that how high this acceleration is. Okay, the beginning of testing all of this has been done by this pilot named John Stapp. Okay, this is the US Air Force pilot, and his testing image is right here. Okay, basically he sat on a rocket jet, and in that case it was hugely accelerated in the upward direction, and then it came down. Okay, so this was the testing done on his body. He volunteered for this, and as a result we were able to actually discover a lot of things.